Hello guys, our today's lesson is the IUPAC nomenclature of bicyclic compounds. These are some examples of bicyclic compounds. Example 1, 2, 3, 4 and 5. These are actually fused ring systems where two 3-membered rings are fused, 4-membered rings are fused, one 4-membered and one 5-membered rings are fused, two 5-membered rings are fused. Here two 6-membered rings are fused, etc. And example 6, 7, 8, 9. Look at here. This is actually 1, 2, 3, 4, 5. This is a 5-ring system. But there is 2 rings there because of the connection of these 2 carbons. Here again, there are 2 cycles are there, so it is bicyclic compound, number 8 and then number 9. Let us we can think about what these are actually 3D structures. So we just visualize this structure in this way. This is actually bicyclic compound. Look at here. This is a bicyclic compound. One ring is here, 1, 2, 3, 4, 5, 6. That is 6-membered ring. 1, 2, 3, 4, 5, 6. It is a 6-membered ring. And this 2 carbon is actually the bridge between these 2 carbon. So it is a bicyclic compound. We can think this reaction, this structure in this way. That look at here. If we omit this 2 carbon, we just disconnect this 2 carbon. Okay, this is a 6-membered ring. This is a 6-membered ring, cyclohexane ring. Now these 2 carbons are attached by these 2 bridge carbons. So I can make the bridge in this way. This is the carbon. These are 2 carbons which make a bridge between these 2 carbons. So this is actually a bicyclic system. This is a bicyclic compound. Okay, this compound can be visualized in this way, that if we look this structure from this angle, you will found this structure as like this. So these 2 structures are actually, look at here. If we look this structure from this angle, you will find this. And if you take a look this structure from this angle, you will find this. So this is the structure. We can write the bicyclic compound in this way because the visualization is different. It is visualized from this angle and it is visualized from this angle, this one. Okay. Now what is the rule for the IUPAC nomenclature of these compounds? First of all, let us know what is the rule for the nomenclature of these compounds. The rule is the substituents first. First of all, you have to write the substituents. Then you have to write bicyclo, because these are bicyclic compounds. Bicyclo. Then you have to write within parenthesis A dot B dot C, and then close the parenthesis. Then the primary suffix primary suffix and then the secondary suffix. Then the secondary suffix. Okay. Now, what is substituents? In these compounds, there are no substituents because these are non-substituted. These are non-substituted bicyclic compounds. Bicyclic compounds. Okay. Now, what is the significance of A, B and C? Look at here. If we consider any one of the bicyclic compounds, actually these two carbons, this and this one, these are known as bridgehead carbon. These are known as bridgehead carbon. These are known as bridgehead carbon. Because these two carbon definitely, this one and this one, because these two carbons are situated at the bridgehead position. Look at here, this is a bridge, this is again a bridge, this is again a bridge. So these two carbons are the bridge. These two carbons are bridgehead. So these two are bridgehead carbons. Now what is A? It is a maximum. It is a maximum number of carbon. Maximum number of carbons present at the ring, definitely excluding the bridgehead carbons. Excluding the bridgehead carbons. Okay. Now what is B? B is the minimum number of carbon. Minimum number of carbon present at the ring, excluding the bridgehead carbons. And A, what is C? Now, C is the number of common carbon atoms. Number of common carbon atoms of the two rings. And of course excluding the bridgehead carbons. Okay. Now what is primary suffix? As we learned earlier, primary suffix is actually the nature of carbon chain, and the secondary suffix is actually any functional group present in the compound. So, maintaining this rule, we can name the bicyclic compounds. Look at here, the first one. There is no substituents, so it is non-substituted compound. So, the name of the compound is bicyclo. Look at here, what is A? Maximum number of carbons present at the ring, excluding the bridgehead carbon. These two are bridgehead carbons, this one and this one. So there is one carbon, this is one carbon, excluding the bridgehead carbons. So this is 1 for this carbon, 1 for this carbon, and 0 for this carbon. There is no other shared atoms except the bridgehead carbons. So bicyclo 1, 1, 0. There are 1, 2, 3, 4 carbons are there, so it is butane. Okay. In the next example, these two are bridgehead carbons. So this is bicyclo, two carbons there, so this is 2.2.0, 1 2 3 4 5 6 carbons are there. This is hexane. Next, this compound, this one is bridgehead carbon, this one again bridgehead carbons. Look at here, 1 2 3 1 2, so 1 2 3 4 5 6 7 carbons are there, so it is bicyclo. There are 3 carbons are there. In this ring there are 2 carbons are there, excluding the bridgehead carbon again. So this is 3.2.0, 1 2 3 4 5 6 7 carbons are there, so this is heptane. Okay, what about this one? These two are bridgehead carbons, so 1 2 3 carbons are there, 1 2 3 carbons are there, so it is bicyclo. 1 2 3 1 2 3, 3.3.0, and there are 1 2 3 4 5 6 7 8 carbons are there, so this is octane. Okay, there is no space actually, no space there. Okay, what about this one? This compound is known as decalin. This is known as decalin. Okay, these two are bridgehead carbon. This decalin is a trivial name of this compound. This is bicyclo. 1 2 3 4, 1 2 3 4, so this is 4.4.0, 1 2 3 4 5 6 and 4 10, so this is decane. Next, what about these 2 carbons? What about this compound? These two are bridgehead carbons. Bridgehead carbons are there. So bicyclo. 1 2 1 1. So this is 2. Definitely ABC should be written in the descending order. Definitely. That is, A is the maximum number of carbons, B is the minimum number of carbons. So A is the maximum number of carbon, 1 2, B is the minimum number of carbon, this is 1, and C is again 1, excluding the bridgehead carbons. So this is 2 1 1. Total carbons 5 and 1 6, hexane. What about this one? We can write here. Okay, this is 1 2 3 4 5 6 7 carbons are there. Here are 2 carbons, there are 2 carbons, and there is 1 carbon. So the name of this compound is bicyclo. 2.2.1, total 7 carbons are there, this is heptane. Okay, next, what about this one? There are 2 bridgehead carbons, 1 2 3 4 and 5 6 7 8, 6 7 8. This is bicyclo. 2 carbons are there, 2 carbons everywhere. So this is 2.2.2, total 8 carbons are there, octane. Next, what about this one? These 2 are bridgehead carbons. This ring contains 1 2 3 4 5 6 carbons, and this ring contains 1 2 3 4 5 carbons. So this is bicyclo. 1 2 3 carbons are there, 3.2 carbons there, 2.1, and total 1 2 3 4 5 6 7 and 8 carbons are there, 1 2 3 4 5 6 7 8. So this is octane. Okay, these are the non-substituted bicyclic compounds. Now let us take some examples of substituted bicyclic compounds, the nomenclature of substituted bicyclic compounds. Now this is substituted bicyclic compounds. Now first of all you have to number this carbon chain, the carbons present in the ring. Look at here, the rules of numbering is like that. The bridgehead carbon is number 1 always. Now the large ring, the most carbon containing ring is written as 2, numbered as 2. This is 3, this is 4, this is 5, 6, 7 and then 8. You have to number first the large ring and then the smaller ring. So the name of the compound is 8-chloro. The substitution is at 8 position. So the name of the compound is 8-chloro. Definitely bicycle. There are 1, 2, 3, 4 carbons and there are 2 carbons. So 4, 2 and 0. No carbon there. 4, 2, 0. Total 8 carbons are there. Oct and 2 in. Double bond is at 2 position. Next, you have to number first. This is the carbon number 1. This is 2, 3, 4, 5. Now this is your 6, 7 and this is 8. Okay, next, what is the name of the compound? The name of the compound is 8-chloro. Again, this is carbon number 4. The name of the compound is 8-chloro bicyclo. Look at here. Here is 1, 2, 3 carbons are there. Here there are 2 carbons, 3, 2 and there is 1 carbon. So 3, 2, 1, 8 carbons are there, so octane. Now let's take the next example. This is carbon number 1, bridgehead carbon. Then this is 2, 3, 4, 5, 6 and then 7. Okay. What is the name of the compound? You have to write the substituent first. The substituent is 7 bromo and 2 hydroxy. So alphabetically bromo first. 7 bromo, 2 hydroxy, bicyclo. There is 1, 2, 3, 4 carbons. Here is 1 carbon. So 4, 1, 0. No double bond or triple bond there. So there are 7 carbons are there. So it is heptane. Okay. What about the next one? The numbering starts from here. 1, 2, 3, 4, 5, 6, 7, 8 and 9. Name of the compound is 8-methyl. Methyl is here. It is 8-methyl bicyclo. How many carbons are there? 1, 2, 3, 4. 4, 3, 0. And 9 carbons are there, so it is non. The double bond is at 1 position, non-in, maybe non-1 in. Okay. Next one. Numbering starts from here. Definitely it will move in this way because the two rings contain same number of carbons, and carboxylic acid is preferentially at the higher position in the preferential series of the functional groups. 4, this is 5, this is 6. Okay, this is 7, 8, 9 and 10. So the name of the compound is 7 chloro 10 hydroxy. It is 7 chloro 10 hydroxy. Bicyclo. How many carbons are there? 1, 2, 3, 4 are there, 4 and here. So 4.4.0, and at the 3 position it is carboxylic acid. Total 10 carbons are there. So this is decan carboxylic acid because this COOH is not counted. This carbon is outside the ring. So decan carboxylic acid. Carboxylic acid. Next, what about this one? Again the numbering starts from here. 1, look at here, this ring contains 1, 2 carbons here, 1, 2, 3 carbons here, so numbering will go in this way: 3, 4, then 5, then 6, then 7, then it is 8. So the name of the compound is, I can write here. The name of the compound is, there is no substituents other than cyanide. So bicyclo. Here it is 1, 2, 3, here is 2, so it is 3, 2 and 1. 1 carbons here. Oct, 8 carbons. Oct, 6 in carbonitrile. Now let us take some other examples of substituted bicyclic compounds. Look at here. The numbering of this the carbon starts from here. This is carbon number 1, this is 2, this is 3 because functional group is present there. 4, this is 5, 6, 7, 8 and 9, 10. This 7, 8, 9, 10 is actually immaterial because these two parts are actually identical. Okay, so the name of the compound is, no substitution is there other than the hydroxyl group. So the name of the compound is bicyclo. 1, 2, 3, 4 carbons are there, 2 and 2 there. So 4, 2, 2. 10 carbons, that is decan 3 all. Alcohol is there. The next compound, the numbering starts from here: 1, 2, 3, 4, 5, 6, 7, and this is your carbon number 8. So this is an amine. So the name of the compound is bicyclo. 1, 2, 3 carbons are there, 2 and 1 there. So 3, 2, 1. 8 carbons are there. So oct amine, 2 amine. Octan 2 amine. Okay, next, the next example, this is very important. The name of the compound is camphor. This is camphor. The name of the compound is camphor. So this compound can be written in this way also. It can be written in this way. 2 methyls are there. Here is a 2 methyl. 1 methyl is there and 1 keto is there. So this one, actually this one, the name of the compound numbering starts from here. Numbering, this is 1, this is 2, this is 3, 4, 5, 6, and this is your 7. So the name of the compound is 3 substitution are there, 1 and 7, 7. So it is 1, 7, 7. I can write here 1, 7, 7 trimethyl bicyclo. This is bicyclo. 2 carbons are there, 2 carbons and 1 carbon they are there. So 2, 2, 1, 7 carbons are there. So heptane 2 one. This is the IUPAC name of the compound Camphor. Okay, this one is here. Okay, next the 3 compounds. These are very important 3 terpenoids. Terpenoids compound. This one is known as alpha pinene. This compound is alpha pinene. This compound is beta pinene, and this one is camphene. Okay, so this compound can be written in this way also. First of all, look at the structure of this compound. This is your alpha pinene. Here, this is the structure of alpha pinene. Look at from here. What you have seen is written there. Look at here. This is carbon. This is methyl. This one methyl. This is double bond. This double bonded carbon. The cycle is here. 6-membered ring. 1, 2, 3, 4, 5, 6, and this carbon is there, CH2 is there, and this carbon contains 2 methyl group are there. So this is the structure of alpha pinene. This is the structure of alpha pinene. One important thing, in many books it is written in this way. In many books it has been written in this way. In this way. Now what does it mean? What does it mean? This carbon is actually above the plane in front of you. So this compound can be written in this way. Look at here. If we look this compound from this angle, if you just rotate this compound, visualize this compound from here, from the back side, you will find this one. Look at here. This one. Now the structure of the compound becomes this one. Now look at here. This carbon go back, and this carbon containing 2 methyl groups is comes in front of you. So it can be written in this way. It can be written in this way, like this. Like this. Okay. Written in this way. So in many books it has been written in this fashion. What does it mean? It means that this carbon is in front of you. Okay, these 2 compounds are actually same. Very important visualization. These 2 compounds are actually same. Now let us consider the IUPAC name of this compound, alpha pinene. The name of the compound is, the numbering starts from here. This is your 1, This is a bridgehead carbon. This is 1, this is 2, 3, 4, 5. This one is 6 and this one is 7 definitely, because this carbon contains 2 substituents. So the name of the compound is 2,6,6 trimethyl bicyclo. The number of carbons is 1, 2, 3 there. Here is 1 and here is 1. 3, 1, 1. Total 7 carbons are there in that ring. So this is hept, and 2 at the 2 position there is in. There is heptoin. Similarly, this is beta pinene. This compound can be written in this way. The numbering is like that. The numbering is like this: 1, this is 2, this is 3, 4, 5, this is 6, and definitely this is 7. So at the 2 position there is methylene group. At 6th position there are 2 methyl groups. So the name of the compound can be written in this way, that 2-methylene 6,6-dimethyl bicyclo 1, 2, 3 is there, and 1 is there, 1, 1, 3, 1, 1, 3, 1, 1, and total 7 carbons are there. This is heptane. This is heptane. And the name of camphene is in the similar way. The name of the camphene is, the numbering starts from here: 1, this is 2, this is 3, this is 4, this one is 5, and this one is 6, this one is 7. Okay. So the name of the compound camphene is again 2-methylene, or this 2-methylene can be written later also. So it is 2-methylene 3,3-dimethyl bicyclo. Here 1, 2, here is 1, 2, and here is 1. There is 2, 1, 1, 2, 2, 1, 2, 2, 1. Total 6, 7 carbons are there, so it is heptane. So these 3 compounds, alpha pinene, beta pinene, and camphene, these 3 are actually the major components of turpentine oil. These 3 are the major components of turpentine oil. Turpentine oil, which is extracted from the tree, from the pine tree, which is extracted from pine tree. So these 3 are actually terpenoids. Okay, this is all about the IUPAC nomenclature of non-substituted and bicyclic and substituted bicyclic compounds. Thanks for watching the video. Thanks a lot.